Today we are here to welcome an incredible, out of this world Lego person, real life astronaut, Jenni Gibbons, space. Talk to us about her mission, standing by to support the Artemis II mission for NASA around the moon. She's going to tell us a bit about her journey to become an astronaut. As a mother of a 2-year-old daughter, demanded space toast this morning. I'm very going to tell us about opportunities for young people, and she's going to tell us a little bit about her work today, preparation with the Canadian Space Agency. Before we welcome Jenni Gibbons to the stage, welcome our very own Jenni Space expert. Jenny King is our student programs manager and also curator of our Lego Artemis exhibition, which will be opening in the summer. This will be an adventure in Lego based on the Artemis mission, so really hope you'll come and join us for that. Jenni, I think I'll welcome you to the stage. Thanks, everybody. Enjoy.
Thanks. So, hi, everyone. I am not the Jenni that you are here, but before Jenni Gibbons does come, I would really like to share something awesome with you that I think you'll fit in. If you are interested in space exploration, and I'm guessing that many right now definitely are, if you like to build, if you like to discover and explore, or if you simply dream of the stars, we have an exhibit opening next year that's perfect for you. Artemis Adventure with Lego Bricks, opening in the summer of 2025, will invite you to embark upon an interactive adventure from Earth to the moon and beyond. This feature exhibition includes giant custom-built Lego sculptures, showcasing tools, technologies, and milestones from the history of space exploration, as well as both free-form Lego building and problem-solving build challenges to get you thinking like an Artemis mission specialist. Please stay tuned for more details from us in the coming months. We hope that all of you future astronauts, engineers, scientists, and artists will join us here next year for Artemis Adventure with Lego Bricks. And now I would like to tell you a little bit about our very special guest today. Jenni Gibbons was born in Calgary, Alberta. She studied at McGill University in Montreal before earning her PhD in engineering at the University of Cambridge in the United Kingdom. Prior to joining the Canadian Space Agency, Dr. Gibbons served as an assistant professor in combustion at the University of Cambridge Department of Engineering. Jenni was selected as an astronaut candidate by the CSA in July 2017. She completed the 2-year astronaut candidate training program and officially earned her astronaut title in January 2020. To hear the rest of her story, let's please welcome to the stage Jenni Gibbons.
Thank you so much. That was a very generous, beautiful set of introductions. I feel very lucky. Already figuring out how to come back to play with Lego and Artemis next summer. That sounds beautiful, and I wish I were a Lego person perhaps, and I also don't know how to make space toast, but I'm willing to learn. So thank you so much for having me. I'm going to talk a little bit about what it's like to be an astronaut. Most people, when they think of being an astronaut, they think of going to space. But there's a lot more to it than that, and I always like to tell people that my main job is I am a professional learner. I spend all of my time with some amazing teachers, as many of you do as well, and my job is to soak it all up, understand it, and apply it. I'm a professional learner, and so is every other astronaut that you'll be able to meet in your lives, and you will become a professional learner too, hopefully in whatever you end up doing, but especially. I want to start by showing you a really cool picture. This is a picture of the International Space Station, which is a space station which is right now above our planet. It's 400 kilometers above the surface of the Earth, which is not that far up. And it's been there for over 20 years. Keep coming in, everybody. Very casual, anytime. Oh, I love it. I have an astronaut suit, my favorite. It's been there for over 20 years, and now imagine you are an astronaut and you are on your first mission. And you're going to space in this modern age. So when you go to space right now, you go to the International Space Station. You usually go for 6 months to 1 year. And let's say you're 2 months into your mission. You've gotten used to it. You've gotten used to looking out the windows and seeing the sun against a black sky. We're used to here on Earth seeing blue around the sun, but you're in space. You don't have the atmosphere, so just against black. You're used to apparent weightlessness floating through the space station. You're used to doing science every day, learning new things we've never learned before up in space to make people's lives better here on Earth. And let's say you've just finished your evening conference with Mission Control back in Houston. You're about to have dinner with your colleagues from around the world who are also up there with you. You're up there with a Russian cosmonaut, a Japanese astronaut, an American astronaut, and you float down to the Japanese module and you look out the window and you see this. You've seen it every day for 2 months. You'll see it every day for 4 more months, but it's still breathtaking. This is what engineering has done for us in space, and Canada is a part of it. It is absolutely incredible. Science, technological development, all the things that we've gotten from this, continually having humans in space for over 20 years. That is incredible. I also love this picture beyond giving us that astronaut point of view because in it, these are solar arrays or solar panels. It's how we generate power on the International Space Station. And you'll notice there is some overlap. Kind of looks like there's maybe 2 right here, 2 right here. Well, there are. We deployed additional solar panels on the International Space Station. And I love this because this is the first piece of space hardware that I interacted with. I touched, I helped send it to space, and I helped deploy it because I was in mission control, in ground with the flight control team with Houston, talking to the astronauts who deployed it on the International. This is a big part of my job. I say I'm a professional learner, but I spend much of my time on the ground learning how to support missions and support the astronauts that are in space right now. They're a very, very cool part of my job and how I've spent a lot of my time since I've been in the astronaut corps. But things are changing. Things are changing because we have decided to go back to the moon to learn even more. How many of you have looked up at the moon and wondered what it's like to be on it? Yeah? I definitely. Well, over 50 years ago, we sent people to the moon, and we learned a lot. We learned a huge amount. We learned what the moon was made out of. It's kind of like this time capsule in our own backyard. The same things that have happened to our Earth have happened to the moon. But on Earth, we have weather and vegetation and erosion and an atmosphere, and we have a changing Earth. All these processes that are kind of changing what we can discover about our own planet. But we don't have that on the moon. When we go to the moon, we learn a lot about our own planet, and we did that with this Apollo program. But we haven't been back since. And I like to show this photo because for those of you who have followed the Artemis missions, the adults in the room, this is a photo taken from an uncrewed mission called Artemis I, which flew around the moon. This is during its lunar flyby, and this was taken automatically by some engineers that were working in mission control who pointed a camera on the solar array of Orion, this spaceship, back at the moon, and they took this picture. And this picture is something we have never seen before, and it is an early gift of the Artemis program. We are going to send 4 humans on this spacecraft called Orion around the moon, no earlier than September 2025. So it's coming up. I see this picture and I'm really proud that Canada's a part of it, that we're going back to the moon. I'm excited for what we're going to learn. This is the rocket that's going to send us there. It's a huge rocket. It's called SLS, the Space Launch System. Talk more about the rocket in a second, but I'm just as proud when I see the picture. And the reason why I'm proud of this is because this guy right here is one of my best friends. This is Jeremy Hansen. He's an astronaut who's been in the astronaut corps a little longer than I have, and he is going to fly around the moon. Imagine flying around the moon, what you would see, looking out your spaceship window and seeing a view no one has seen. You see the moon, and you see Earth. every place you've ever been up until that moment. Everyone you know besides the 3 people who are in that capsule with you, a completely new view. What would you do if you saw that view? How many of you would take a picture? I would take a picture. Jeremy's going to see that view and he's going to take a picture and he's going to show all of us. And it is going to be a view that no one has ever seen before. They're going to do science on this mission, test a lot of the systems on their spacecraft, get ready for humans to land on the moon. We have a couple of other friends in this picture. This is Victor Glover, the pilot of the mission. This is Reed Wiseman, the commander. And this is Christina Cook. She's a mission specialist like Jeremy. But Jeremy is the only international partner, non-American, Canadian, on this mission. And my job is to back him up. So I do all of the training that Jeremy does. If everything goes as planned, as it should, Jeremy will fly to space, and I will be one of the people in mission control supporting that mission, talking to him. Can't wait. I'm going to talk a little bit about the mission, what it actually is going to look like to fly around the moon, but I'm going to do it with a video. So for all the little ears that are in this room, it's loud. We're going to watch what it's going to look like to see a rocket launch. It's going to be really cool, and I'm going to talk over it. So I'm going to try and tell you what's happening, okay? But this is kind of the overview. After we launch, we're going to go around the Earth and then do what we call burns, which means we light our engines, and we go around the moon for a lunar flyby, and then come back to Earth and land in the ocean. Ready? All right, let's go. Launch. All right, this is that rocket. It's a space launch system. It's going to launch from Florida. After launch, solid rocket boosters, the biggest engines, are going to separate, and then the core stage is going to separate. You're left with this. The solar panels deploy around 20 minutes into flight. There's the Orion spacecraft with the crew in it. Do a couple burns, change your orbit, and then you separate from the upper stage. This is one of the coolest things we're going to do. We're going to use this upper stage as practice. Practice for when we have a lunar lander and we have to do something called a rendezvous in space, in orbit. We're going to test the handling qualities of the Orion spacecraft. It's something called the rendezvous and prox-ops demonstration. A lot of big words. We're really just practicing here. But we're using that upper stage in order to practice. We go around the Earth again in high Earth orbit, really far away, and then we do a big burn of the translunar injection. The translunar injection sends us away from Earth to the moon. On the outbound flight, we do a couple of corrections if we need it, and then we fly around the backside of the moon. It's called the lunar flyby. All those astronauts are going to be taking pictures to show you. The spacecraft's going to come back and separate the crew module, that's the crew and that right up there, from the service module. The service module will burn up, and the crew module will re-enter the atmosphere. It will slow down a lot. The parachutes will deploy, and it's going to splash down in the Pacific Ocean, off the coast of San Diego. It's exciting, right? I'm excited. Excited for everything that is going to be shared with us after this mission. After it splashes down in the Pacific Ocean, it's going to be recovered by the US Navy. The astronauts will be picked up out of the capsule, helicopter lifted to a ship, then returned safely. And Jeremy is going to come back to Canada, tell us all about it. It's going to be amazing. A 10-day mission where the orbital mechanics work out. Humans will go further from the Earth than we've ever been before. They come back, they'll be going faster relatively. During the mission, we'll test things we've never tested before. We'll learn a lot about how to keep astronauts alive in this new spacecraft. We'll learn how to fly the spacecraft to prepare to land on the moon. So you might be asking yourself, oh my gosh, that's a big mission. We're trying a lot of new stuff. How do we get ready? Well, just like you have anything else coming up in your life that you have to get ready for, practice. So we practice what it's like to be on this flight in every phase of the mission, every part of the mission? Here, great question. Who I think is me, if I understand your question correctly, I'm in a spacesuit. This is for those who are interested in spacesuits, because people always really like suits. This is called the OX suit, or the Orion Crew Survival System, OCS suit. It's a special suit that keeps you safe when you launch and re-enter on Orion. And you have to get fitted for it, just like you go and get fit for your clothes if you try them on in the store, but a lot more expensive than that. So I'm wearing the spacesuit, and I'm in the seat, or a mock-up of the seat, and you might not know this, some of you probably do, but when you launch to space, you do it lying on your back so that the thrust vector is going through your chest. It's much safer for us humans to launch that way. So we practice that. We practice some very fun stuff too, like eating lunch. I like to eat lunch in space. What's the food like? Well, we taste it. Here I am with a couple of my friends I showed you earlier, here with Vic and with Tina. And we're practicing a day in the life in Orion. You might have noticed Orion, that spaceship, looked pretty small, about the size of a minivan. 4 people are living in there, eating, sleeping, practicing, exercising, everything that you might need to do to keep yourself healthy for those 10 days. On this day, we were practicing all of the things that you have to do on your first day in space, including having lunch, so this was a nice break for us. And we also practice what it's like to come back after 10 days in space. Your body feels different. You might be feeling kind of sick, actually. What happens if you land in the ocean and something goes wrong and you have to get out of the space? This is what we're practicing. This is in a facility some of you might be familiar with called the Neutral Buoyancy Laboratory in Houston, Texas, part of the Johnson Space Center. And we're practicing what happens when you have to get out of the spacecraft quickly and get to a raft and then call an emergency services to pick you up, basically. We also practice this in the ocean. Here I am in the Pacific Ocean. This was a test in February, I believe. And these recovery forces are helping me out of the capsule. I'm going to a raft there, and then remember I said a helicopter would come pick us up and take us to safety. All that happened in the test, and this is just more practice. Practice for me and practice for these guys and gals to help us when we get back to Earth, even if everything goes well. Well, we talked a little bit about the Artemis II. But what comes after that? Well, we talked about landing on the moon. Landing on the moon is hard to do. We've done it before, but we've not done it with this set of craft, this infrastructure, astronaut, this ground team before. And we've not done it in the place that we're looking at. We're looking at going to a new place on the moon. I'll talk about that in a second. When you land on the moon, you're not flying like an airplane through the atmosphere. Chances are you're going to land on the moon vertically. Take off vertically. Not exactly like a helicopter, but kind of like a So we do a lot of helicopter training. I had the pleasure of doing a couple of familiarization flights and learning how to fly helicopters with the Canadian Forces Flight Training, Portage La Prairie. And again, you don't have an atmosphere when you're landing on the moon, but a lot of the things that you see will be similar. You're going to kick up a lot of dust if you have a propulsion system, hopefully bringing you down to the surface, just like helicopters kick up a lot of dust. It's very hard to tell how far you are away from things, how big boulders are. You get a lot of what we call spatial dislocations, potentially when you're flying a helicopter, especially if you're flying them in Canada in snow. It's a very hard thing to do. So we learn from people who have that experience in order to prepare to go to the moon. And then when you're on the moon, how do you move stuff around? When people send things to you and they land, now that you're already there, stuff lands on the moon. How do you get that food, get those supplies, get that water, get that air that you need to survive? Practice that too. This is a test called sea test in the ocean. And it's just one of the other ways that we practice. We practice underwater. And we practice underwater because when you scuba dive, scuba is a self-contained. Many of you have done that before. Which is not that different from a spacesuit. And when you're underwater, you can add weights to yourself to make it seem like you're in 1/6 gravity, like the moon. And you can practice talking, communicating with your team, with someone like Mission Control, if you've heard the Apollo tapes, and practice moving all the things that you need to an airlock or a pressurized rover. Just another one of the ways that we practice. And when you're on the moon, well, we're going there for science, right? We're going there to learn. I love sharing this particular piece of training because it's close to home. What's one of the first things that you notice when you go ahead? Anyone? Oh, it looks like a big ray. It kind of does. I agree. Yep. The craters. Love it. Good. Craters. There's craters everywhere. All over the place. We have craters here on Earth too. They're different, again, because the Earth has all of these processes which erode things. But in Canada, in northern Labrador, there is a place which is very, very special. And it's special for the type of rock that's there. Because on the south pole of the moon, the type of rock that's very common is called anorthosite. But anorthosite on Earth is actually really rare. There happens to be a lot of it. For any of you who have heard of labradorite, a very pretty type of anorthosite. And 35 million years ago, we think, a meteorite crashed into what is now northern Labrador and made this beautiful crater. This is a complex crater, for those of you who have studied this before. So we have a region of uplift in the center. It's now a lake called Comistaston Lake. You have a crater which is beautifully preserved into a target rock, which is just like the target rock on the south pole of the moon, which is completely unique. No other place in the world has something like that. And we are fortunate enough to have it in Canada. So we go there. Here I am with Jeremy in Comistaston, and we are working with a geologist to try and learn what the best and most scientifically valuable rocks that you could pick up on the moon are. Because when you're there, imagine now, you've done your ISS mission, you're, let's say, on Artemis 4, 5, or 6. It's your second mission. You're going to walk on the moon. How cool is that? You're in a spacesuit. You've practiced. You've done all those tests that I showed you before. You learned how to land. You learned how to move things around. You're there with Jeremy, let's say, and you're walking around on the lunar surface. But it's just the two of you. There are hundreds of thousands of scientists on the ground who have made it their whole life's work to study the rocks on the moon. And you get to be there, and you get to describe those rocks, pick which rocks we're bringing back to Earth. You want to know what to pick, right? Hopefully you pick some good rocks. This is what we were learning how to do. Right? I can hard relate, let me tell you. Got a couple of them, got a lot of rocks. I learned a lot on this trip. Do you have any geologists here? Okay, good. Just kidding. I love geologists. But if a geologist ever tells you when you pick a rock that it's pretty, you should put that rock back. You have failed. That is not the kind of rock we're looking for. They're trying to make you feel better. We want ugly rocks. We want rocks with all kinds of other rocks in them. We want breccias. We want rocks with anorthosite and target rock and all sorts of junk in them, and then melt from the crater, melted rock that froze and turned into a solid on that rock. That's the rock that we want to bring back from the moon. So that's what we were learning how to do, how to pick best rocks. Those geologists are very patient people. Eventually, they stopped telling me the rocks that I picked were pretty, and that was a great moment for me. So hopefully, we can take pride in the fact, though, that every astronaut which is going to go to the moon in the future is going to come to our own backyard in Labrador and learn how to pick rocks for them. Because that site is so unique, it is one of the science sites for the future Artemis mission. That's really cool, the fact that Canada can do that. Comistaston is also a very beautiful place. It is on the traditional and spiritual hunting grounds of the Innu people, and we were there with permission with cultural guardians from that group, and they were so generous with us. They have known that that place was special for a very long time. We were fortunate enough to be invited to go there with them, and they guided a lot of our work during our time there. It was one of the best training experiences I've ever had, and it was in our own backyard. We also go to Iceland. Here I am with my friend Tina, and we are walking around in one of the Apollo training sites. Apollo astronauts went to Iceland as well. It's the other training site to go to the moon to learn how to pick good rocks. And there's no crater like there is in Comistaston, well preserved into anorthosite. Again, that's unique, not like in Canada, but it looks a lot like the moon, right? Isn't that kind of what the moon would look like? So it's another what we call analog, something that's kind of similar to what we're looking for. Go there as well. A lot like the moon. I want to really quickly go over for the adults in the room, another thing to be really proud of. Might be a little bit beyond some of our younger audience members, but you guys can relate to how cool robotics are if you play with Lego Mindstorms and the like. Well, Canada is really good at robots. We're really, really good at making robots, especially robots for space. We have built 2 Canadarms, one for shuttle, one which is on the International Space Station called Canadarm2, and we have committed to building a 3rd robotic arm called Canadarm3 for the next space station, which is going around the moon, called the Lunar Gateway. And because we did that, because we used all of that expertise, amazing engineering and technological expertise, in return, we got Jeremy's flight, more future flights. That's how astronaut flights work. We are really good at something. We happen to be really good at space, and we make hardware, we make people's lives better, we get all these spin-off technologies, and we barter them internationally, and in return, that's how astronauts work. We also are building rovers to look for water ice on the south pole of the moon, eventually to make a base. This is just a picture of what the base could look like. It doesn't exist yet, but if you think about what do you need to build a base on the moon? Well, if there are people there, you need clean water for them to drink. You need healthy food to keep them alive. You need a medical kit to be able to support them, keep them healthy, and you need to be able to communicate. All of those problems I just mentioned are the exact same things. Space is just one way to do them. If we learn how to keep people healthy with good food and clean water, medical kits, and communicate with them, this is one way that we can do that. And the technological developments and spin-offs and windfall that we get from this are going to improve our life here on Earth. It's amazing. I can't wait to see what we learn when we go there. So that's just one glimpse of the future. And all of this, again, is just a reflection of what we can see if we look back at our own planet. All of this is for learning and improving our lives on Earth. And I have a lot of friends who've been to space. I'm very lucky. A lot of my friends in the astronaut office who have already flown or gone to the International Space Station. They will fly again soon. And they turn around, they look out the window, space. And the thing, out of everything that they've seen that they always mention is how beautiful the Earth is, how beautiful our planet is, how fragile it is, how they don't notice borders and designations between countries. They see it as a whole, and it's a huge perspective shift. So we started today by talking about the viewpoint of an astronaut and what that feels like and might look like if you go to the International Space Station. And then we talked about what it might feel like when you're picking rocks on the moon, hopefully all the ugliest rocks you can find, and bringing them back for all the scientists to study. And I just want to finish off by talking about how beautiful our planet is, how this is all connected, why we're doing this. So I have talked for enough time. That is all that I wanted to show you as far as pictures and videos go, and I left lots of time for questions, which is my favorite part. So please feel free to ask me.
Would you rather be the first Canadian to go to the moon, or would you rather be the first Canadian to go to Mars?
Oh my goodness. I would be honored to do either of those things. Regardless of if I'm the first Canadian to do anything in space, I hope I'm not the last. So I think that's important to me, not being first, but especially not being last. I want more Canadians to go to space. Maybe some of you guys going to the moon or Mars. I, right now, feel like all my training is moon focused. So I'm going to say the moon. I think that would be so cool if astronauts, we had Canadians. That would be awesome. Hope Canada. I hope we do all of the technological development and engineering required to send astronauts. It would be great for our country. But I would also go to. So if you're sending people, either. Good question. Yeah.
You use the bathroom if every.
Yes. Great question. Love the bathroom question. I love when it happens early because someone always wants to know, and I love that you asked it now. All right. To go to the bathroom in space. First of all, there are a couple of situations where you have to wear a diaper. Mainly a spacewalk, launch and entry. Can't go to the bathroom. Got to wear a diaper. All the other times when you're not wearing a diaper, rather than you go to the bathroom now and you have gravity moving things away from your body, you have suction and space moving things away from your body. So you can imagine you have some sort of funnel, and then you're using airflow to move things away from your body. That's how you go to space, to the bathroom. Not for everybody, but it works pretty well.
Why is the sky blue when we're on Earth and not when?
Oh, because there is no atmosphere. That's a great question. What makes, you're asking me kind of like why we're against a dark sky when we're in space? Why is the sky dark? Because there's no atmosphere that the light is passing. All because of our atmosphere. So when you're on the moon, you would have a dark sky too. Question. Yes. Half one down. Yes.
When we're on the moon, you know, the sun hits the and at night sometimes it reflects off onto Earth. If the sun is hitting the moon, would that be enough for plants to grow on the like inside of domes with oxygen?
Yeah, I think so. You have sunlight on, but the moon is different. It's a great question. And I think, yes, in greenhouses, you can grow plants on the moon. That's one of the projects that Canada is looking at doing. There are some very interesting regions on the south pole of the moon where you have regions that are almost permanently in insolation, so permanently light. And in the craters, it's permanently shadowed because of the lack of tilt on the moon, essentially. So you would need to pick your spot carefully. But yes. Great question. I love this. We have all these people who are going to work at the Canadian. Great for us. Yeah, look at these Canadian Space Agency folks are like,
How have we made such like big advancements in 1969 for Apollo 11, but now today it's been so like more cautious and it's taken so much more to get.
Oh my gosh. Yes. Probably money. I will say that. Apollo had a huge budget. It was motivated by a lot of factors, a lot of political factors, and we sent folks to the moon at great expense. We went fast. For all the adults in the room, have you listened to a podcast called 13 Minutes? Yeah, a couple people. I would really recommend it. I think it's a phenomenal podcast. Maybe you'd like it. And it talks about how we went to the moon. It talks about all those factors. There's a really cool episode called Kids in Control. So we could totally go to the moon right away. We know how to do it. It would be hard to do, especially because we stopped doing it. But it would be expensive, and expensive programs aren't necessarily sustainable. We look at what Apollo gave us so much fast. But America went alone. That program didn't last that long. We still have a couple of moonwalkers around, but they're in there. They want to see more people walk on the moon. Then we have the ISS program. The ISS program is lasted more than because we have had international partners from all around the world. There's a Russian segment, US segment. There are astronauts from all different nations, national space together. It costs less, we do it better. And with Artemis, we're trying to go together too, by Canada. But to go fast, it would cost more money. Totally have the technological capability to do our priorities. We've got a lot of priorities. Yeah. Interesting fact that I've learned about the moon. Okay, so I've kind of already talked about it, but I thought the fact that Northern Labrador is kind of like the moon was one of the most interesting things that I could learn about the moon. The fact that we, despite how different the moon looks, no atmosphere, or very, very thin atmosphere, no vegetation, liquid water, and yet we could go someplace so close to home and learn so much about the moon, so much about going to the moon. That was really, really cool to learn about. I've really liked learning about all of the information that was provided by something called the Lunar Reconnaissance Orbiter, or LRO. It's all available online, and if you're interested in the moon, it shows us incredible pictures of the lunar surface. That's been really cool because you can zoom in on all of the craters and look up Shackleton Crater, South Pole, craters. That's really cool. Learning about what I mentioned, those permanently shadowed regions, has been really interesting because they're really, really cold. Some of the coldest places you can imagine. And they're right next to places that are permanently lit, hot. So whenever in engineering you have temperatures like that, that's a really interesting show about and use. Cool. I recently learned about telescopes that you can put on the moon. You don't have an atmosphere. You don't have any of the geological activity that we have here on Earth, which makes it difficult to observe our atmosphere, along with like the pollution, satellite clusters that we're. That would be really cool to see. Yeah, I've learned a lot about the moon recently. Still by no means an expert, but there's a lot there to learn.
Do you think there is space?
Yes, there is gravity in space.
Correct.
Oh my gosh, was that a quiz? And I passed? It's a great question because a lot of people say there's no gravity in space, but of course there's gravity. Gravity is just the force of mass attracting, right? But when you're in orbit, you know all this already, I can tell, right? Yeah, you do. But when you're in orbit around the Earth, it's like you're falling. You're just going really, really fast. That's what orbit is, right? Did I explain that right? And you're a little bit further away from the surface of the Earth, so I would say the gravitational force that's on the International Space Station is probably like 95% of what it is here on the surface of the Earth that you're feeling toward the Earth. But since you're in orbit and you're falling all the time and you're going that fast, you're in apparent, call it, feel like you're in zero. Not. Yeah? Any other questions there? I really liked that. That was a great question. I didn't know it was a quiz, but I didn't panic.
Have you ever been near the sun?
I have never been near the sun. I have only ever been to planet Earth. One day I hope to leave on a rocket ship back. But I've been as close to the sun as you have. Question?
What happens if someone gets stuck on the moon?
Oh, if someone gets stuck on the moon, if you were stuck alone on the moon, it'd be pretty bad. There are lots of movies and books about this. The Martian is one of them, getting stuck on Mars. And that was actually pretty good. It was like a pretty good scenario playing about how to look after yourself or stay alive, I would guess, if you were stuck on the surface of some place that wasn't Earth. But if you were stuck on the moon, we would send help, try and get you back. You would have to employ a lot of your survival skills, a lot of the procedures that we trained for. We train for all of the bad days in space. It's rare that we train for like a good day, except that one photo where that was a great day. But otherwise, we're pretending everything goes wrong. What are you going to do to stay alive and hopefully get home safe? Your crew safe. Maybe save the mission if you save yourself and your crew. So if you were stuck on the surface of the moon, we would do everything that we could to help. We would send people to help. If we could get there, we would talk to you, try and guide you, try and help you in any way we could. We'd communicate all the resources we had there, and hopefully we can get you home safe. We haven't left anybody else.
If you met somebody had a dream to become an astronaut, what would you advise them?
What would I advise them? Yeah? I would tell them one thing I've already mentioned, which is how important learning is. I think it's really easy to look at an astronaut and say, wow, they are there, they know so much, I don't know so much. Maybe we'll have these thoughts of self-doubt that everybody has, frankly. Everybody has these thoughts when they're trying to pursue something they really care about. My best advice would be that you're very, very best at learning. Find something that you absolutely love, that you're really passionate about. For me, that was thermodynamics and combustion engineering. I love the idea of using science to creatively problem solve and help. That's engineering. I would say find what you love to do it a lot, get really, really good at it, share your passion with people, talk about it, set goals. Every day, work a little bit toward that goal. The combination of all of these things, which are very much related, being passionate about what you do and like finding something, working a bit, things every day, every day, I would say those are the most important things. And then as you get interested in other things, those will be important to you in other ways, no matter what it is that you're wanting to work on or work toward. And hopefully you set yourself up well to apply to the astronaut program in the future. There are more specific recommendations that I can make as well, depending on what you're interested in. But I think those are like the key things that you really, really need in your career before you transition to an astronaut in order to. Question.
How do you drink coffee in space?
It's instant, which I don't mind. But some people I know don't like coffee as much. So if you're in the International Space Station, you have coffee which is dehydrated, similar to what you would have if you like instant coffee, or let's say if you're camping, and you mix water into it. There is a water dispenser on the International Space Station, and you mix it up, and you can drink it from a pouch, or there is a specific cup that you can use, which uses surface tension, essentially to keep the coffee in a position where you can drink it. But obviously, you can't be like pouring coffee around, and you can't make coffee the way you make it on Earth and hydrate it. A lot of our food on the International Space Station, and we rehydrate it and heat it up or mix it up when we're up there.
The first moon landing was done a long time ago. Then how come they can't do it now with better technology? And if NASA is a big company, don't they have lots of money?
Well, the key here is that NASA is a big government agency, which means that the money that they use to go to space is money from people. Money from the US government, just like the Canadian Space Agency, is funded by Canada. So we have to decide that space is a priority because there are so many other things that we want to work on to make our lives better as well. So they don't have a ton of money. Their budget is much smaller than it was in the Apollo days. If they had a ton of money, we could do a lot. We are still doing a lot. We are still going to the moon and going to land on the surface. It just takes time. We have commercial partners that are bringing us there too. But the pace of Apollo was fast. It was an expensive program. But I really like that you mentioned the fact that we had this technology, but it doesn't mean it was easy. Like if you actually think about what the Apollo program did, it is wild. In the 60s, we built a rocket, Saturn V, as big as a skyscraper, put it together with the precision of a watch, and we sent it 250,000 miles away. We did it multiple times, and we brought everyone back safely. There were accidents on the ground, but that is incredible. And because we learned how to do that really, really, really hard thing, make no mistakes, it's really hard. Because we learned how to do that, it's the reason why we have cell phones, the miniaturization of electronics. That was all paved by microprocessors. Apollo. Silicon Valley popped up in the wake of Apollo. All that technological development, because we set that goal of going to the moon, made enormous progress. But it was very expensive. Priority. It's a priority now too, but it's just different. Different. But if we had more money, we'd do a lot. We will do a lot. It's a hard thing that takes time. But I love that you're thinking that way.
How is the rocket ship?
That's the question. I was
How
distracted.
to get into the rocket?
How do I get into the rocket ship? Oh my goodness. It's actually really cool. It takes a long time. Getting into the rocket ship is like, it's hours and hours. So get into the rocket ship. What you do is you have a lot of people helping you put on your spacesuit and get ready. There are like medical requirements the day of. You've probably woken up really early. You've prepared. Everything has to be perfect. There are a lot of tests to make you ready. And then you walk out to the launch tower, go up an elevator, all the way up 274 feet in the air. And then you walk out on what we call the walkway for the spacecraft. You get in the top of the rocket. A lot of people there who strap you into the rocket for a long time. Jeremy flies in space. I might be one of the people strapping him in the rocket. It's astronaut support person, ASP. And then you prepare to go to space. Do all of your procedures. You spend hours in that capsule and in that rocket ship before you actually launch. But people love it. That's a really time. Can you imagine how you that giant rocket as? That's the long answer. I guess the short answer is you just You walk in.
We've got a few more, so
Yeah.
Is it true that apparently at some point was someone
No problem.
there was someone who went on different company, went to satellites that orbit the Earth, and SpaceX had to pick them up? Is that true?
Oh, I think I know what you're talking about. They didn't go to a satellite. They went to the International Space Station. Correct me if this isn't what you're talking about, but this summer we launched 2 crew members on the Starliner, the Boeing Starliner, crewed flight test named Butch and Sunny, the wonderful astronauts, and they went to the International Space Station, but there was a problem with their capsule. There was an issue with it. What you're talking about? Yeah, I think so. So there was an issue with their space capsule, and it wasn't safe enough for them to come. There were a lot of talks on the ground about how to get them back, what felt the best, and for the people who are a bit older in the room, probably remember NASA has a loss of human life, so that changed the way we talk about risk on the ground, the decisions that we make. The truth is, if for the Columbia disaster, we had an opportunity to get those astronauts to the International Space Station, we would have done it. Would not have come home on that shuttle. That, because we could not do that, the chances were slim, did not go our way, had a disaster that resulted in the loss. Because of the lessons that we learned, that had a safe place for them to stay, not to come back on their spacecraft, even though it could have been fine. It was a very well-developed spacecraft, the thruster have to work on, normal in spaceflight. That capsule came back without astronauts, which meant that we have 2 people in space who didn't have a way to get home. So what we did is we launched another spacecraft, happens to be owned by SpaceX, with 2. So now those astronauts can come home. Their mission got extended. If you were to go to space, let's say I would like you guys to go to space. You're going to go for a week. Cool. Yeah, you're in. What if I'm like, okay, great. Now it's going to be 8 months. Still cool. Yeah, that's what these astronauts were like. I mean, they are up there doing this science, living in space. They might do some spacewalks in the future. That's really cool. I mean, they're very happy. They're safe up there, but their mission got extended. So they'll be coming home on a Dragon. I'm pretty sure that's what you're talking about. Okay.
2 more.
Yes.
What if somebody was in a crew and then one person would stay on the Earth, and then its other crew would go on the moon without them? What would they do?
If there was a crew, did I hear that right?
If one person stayed on Earth, the crew went to the moon.
Oh, well, if it's your crew, question correct. If it was your crew's kind of like your best friends. They're like your family. So right now, if you're training with a crew and they went to the moon without you, you'd probably feel sad a little bit because you want to go to the moon, right? Yeah? Okay, yeah, I want to go to the moon too. You'd feel a little bit sad, but if it was the best thing for the mission, that's an okay mission. And I would also be really proud of them. Be really happy for them. Happy for you. I don't know if I 100%, but I think that's.
Last one.
What's the biggest animal ever launched in space?
Animal? Human, probably. Biggest animal ever launched. We, in the early space days, before we did human space flight, there were animals launched into space for tests, which cruel. Yeah, it was cruel, but it was a part of our learning process. The largest animal that we have launched. I won't tell you which human. I don't even know. That would probably be me. Or I'm here trying to think of which of my astronaut friends was the biggest. Jeremy's pretty tall. Yeah. We've also, there was a time when a chimp was in space. There's a dog in space as well. Yeah.
Hey.
I get asked sometimes if we've seen fish or whales. That I know of. That'd be a lot. That'd weigh a lot.
Thank you so much, Jenni. It's been amazing to hear all this. And thank you, everyone, for joining us. That is a wrap for today.